Okay, now I have an 84 also, so I'm going to actually go through both sets of instructions. If you have the 83, pay attention to what I'm going to do first. On the TI-83, if you want to evaluate a derivative of a function, you can go ahead and algebraically take the derivative, but if you're going to have to plug a number into that derivative to find the rate of change of that function at a particular x value, then this is how you want to do it to be sure that you're doing it right. Let's suppose that we're going to evaluate this function, which is a cost function, and we want to find the derivative of that function, the derivative or the rate of change of cost, when x is equal to 9. So what we're going to do is we're going to press the math key and go down to number 8 and select number 8, and if you have the 84, this first step is the same. But with the 83, you have to put in 3 what are called arguments. The first argument is the function. The second argument is what you're going to take the derivative with respect to, and since all your calculator knows is x and y, you're always going to be taking the derivative with respect to x, even if the original function said c of q and the input was q. Just do it as if it were c of x and the input is x. And then you're going to give it the actual number that you want to find the value of the derivative at. It's not going to find the formula for it. You cannot use this process to find the formula for the derivative. You have to do that on your own. But you can use this to plug a number into the correct derivative formula so that you don't mess up the arithmetic. So in the case of this particular problem, we're going to enter in the function 0.002 x raised to the 4th power plus 0.1 x raised to the 3rd power plus 0.3 x raised to the 2nd power, or squared, whichever you want, minus 0.1 x plus 50. So there is your entire derivative formula. Since there was nothing in here that, like fractions or exponents that needed to be in parentheses, this one I didn't have to use any parentheses, but sometimes you will. So just be aware of that. And then at this point you put a comma and you enter the x because that's what you're taking the derivative with respect to. And then you put another comma, and then the last thing that you put in is the value you want to evaluate at, which in our case is going to be 9. And then close your parentheses and hit enter. Now somehow I've gotten a different answer from what is on the screen, so let me double check that I did my derivative right. 0.002x to the 4th plus 0.11 should, yes, it does matter. Yes, I think it does. I think we... Yeah. Let me go up and re-enter my function. because I put too many ones in the last time. Okay. Okay, and well,
Only reason you're not getting that same answer is just because you looked within the screen on the calculator.
yeah, I just saw it. It's misentered on the screens on the calculator, which is really interesting, seeing as how I copied it straight out of the book. I copied that whole set of instructions straight out of the book, but this is the correct derivative. So what happened here is that, let's see, that's right, that's right. Here's where the difference is. So that should say 0.1x. And if you put in the right function, you get the right answer, which is 35.43. Three zeros. And in most cases, it's going to be okay to round your derivative, your numerical derivative, to 2 decimal places. Okay? So we would call that C prime of 9 would be approximately equal to 35.4 or 35.43. If I want a specific number of decimals, I'll tell you. If I don't tell you, then 1 decimal is probably going to be enough unless it's money. If it's money, go to 2, because money has 2 decimal places. Okay? Now, to do the same problem, if you have the 84. And this is why you don't see me very often using the calculator, because it's really hard to get enough light on it for you to be able to read it on the screen. Can everybody read that okay? Not that you're supposed to know what that means, just can you read it? Let me clear off the screen. We're going to do exactly the same thing. We're going to hit Math, go down and select number 8, or just press the number 8. Now, my 84 brings up the exact same thing as before, but some people's 84 does not. If your 84 does not bring up that particular same kind of screen, yours is going to look like this. Okay? So when you get finished putting yours in on your screen, and again, we're going to use the same function that we did before, what you have to notice here is the first thing you're going to enter is going to be the x to go in the derivative box. So the variable is going to come first. Then you're going to put in your function. And then the last thing you're going to put in is, in this box right here, you're going to put your number. So you've got 3 little boxes to fill in. So fill in those boxes with x, then your function, which I'm showing you right here, there's your function. And then at the very end, put in your 9. So if you do that, then your derivative with respect to x of this function evaluated at 9 is going to come out to be exactly what I got on the 83. It's the same answer. Okay? And your interpretation would be the same. C prime of 9 equals 35.4, 35.43 with a dollar sign, depending on is it an application problem or what is it. Okay? Now, just to be sure everybody knows how to do that, and I want you to use your calculator and follow along with me, let's practice a few problems.
Is that the same function? Because I've been using the dy dx function under y equals count and all that stuff. I'll just stop you.
Yeah.
Okay, same thing.
Yeah, it should work. Which one are you saying you're using it under?
I do, like, you know, put the equation, or put the function in for y equals, and then go to second trace, go to number 6, the dy dx function, and then you just type in the
Yes.
pattern.
Yes, as a matter of fact, I can show you how to do that one too. But that one usually is if you graph the function. So if you go, you know, if I graph this function,
I just wasn't sure if it was the same thing.
yeah, it should be the same thing. Let me show you how to do it because this works the same on both calculators. I'm not seeing my graph, but that's probably because my window is way too small. So let me start at 0. And given that I know that larger values on that function are going to go pretty big, let's go up to about 25 and see if we can see it. And then I'm going to do zoom 0. Oh wait, I don't have it in there. No wonder I'm not seeing anything. So let me put the function back in. Yeah, if you've already graphed it, this is really the easier way to do it because it's still doing the same thing. What you do is you type in your function. Excuse me?
0.3 for x squared.
Ah, yes, you're right. Thank you. Not 0.1, 0.3. And then I'm just going to go zoom 0 so I can see the graph. So even though I know that's a 4th power function, this is the part of the graph I need to see, and as long as the number 9 is between x min and x max, I'm going to be okay because I need to be able to see it for the calculator to be able to calculate with it. So then what you can do is do your second trace and go down here to number 6, dy dx, hit enter, and then you're going to have to tell it a value that you want it to do the function at. So type in a 9, and it kind of covers it up. Let me fiddle with the window a second. Actually, that might not be far enough. Let me go down a little bit more. And there it shows you the derivative at x equals 9. It says for some reason it's 16. Do you go to your value first, Seth, when you do it? Do you go find 9 on the...
Oh, no, it's, I just go straight to d by dx, 7, 9.
Okay, so right there I'm at 9. And then second trace number 6.
Press 9.
And yeah, I should, but somehow it didn't look like it was coming up right. Okay, it came up right this time. I don't know what it did last time. But it gives you the same answer. So you can get it on the graph too. The key thing about doing it on the graph though is to remember that your number you're going to plug in for x has to be between x min and x max. You have to make sure that's there. Because if you can't see it on the screen, your calculator can't find it either. So you can do it either way. So what I want to do is we want to practice a little bit just to make sure everybody's comfortable with it. So on our practice sheet, this is what I want you to do. This is to help you, not me. This is not for me. I'm not taking it up for a grade, but this will help you. And on the test, I would want to see this on the test. If you're going to use the numerical derivative, I want to make sure that you put it in correctly. Okay? So find the derivative of the function at the stated value and show exactly how the function is entered into the nDeriv. So what I want to do here is I want to do nDeriv, or if you want to use the graph and do dy dx, you need to have the function, which in this case doesn't need any parentheses, with respect to x at x equals 1. Or if you have the 84, what you see on your screen will look like that. And since I only need to see 1, I'm going to go from -2 to 5 on the function. So there's my function. And from the graph of the function then, I just go second trace, number 6, type in the number 1, hit enter, and it says the derivative is -2. So there's your instructions for how to do that one. Now I'm not going to write down the instructions every time for you, because once you've got them written down once, you should be good. So if we're going to do x over x squared minus 1, actually let me do this. Let's go back and just use it on the screen to show that we do get the same answer. You see there it's a -2. Now, the only difference with my next function is I am gonna have to be careful how I put in that rational expression, because I am gonna need a set of parentheses. I'm gonna need parentheses around the denominator, otherwise it's gonna see x over x squared, calculate that, and then subtract 1, and that's not what you want it to do. So be sure you use the parentheses when you need them. X divided by parentheses x squared minus 1, close the parentheses, enter your x, comma, then x, and then a comma, and this one says that x equals 2. Now, if you get something that looks like that and you're curious as to whether it's a fraction, don't forget, you can always hit math and ask it to convert it, and sometimes it will if it actually came out to an even fraction, but this one didn't. So then we say that y prime is equal to negative 0.556 would be 3 decimal places. If I don't specify, round however you want to, but usually at least 2. Okay? Is this working for everybody? Let's do a couple more, and then we're going to do an application problem, because I know one of the things that you struggle with is how do I answer these questions? Not how do I do the calculus part of the algebra, but how do I answer the question? So, again, we're going to do nDeriv, and our function this time is going to be negative sign, square root, and it opened up your parentheses as it should, 8x plus 1, close the parentheses, comma x, comma 3. So this will be negative 2.70. Yes, I did. I keep forgetting this one repeats clicks sometimes. Okay, now this one thinks it's being smart, because it says the answer is negative 8.00000, but really, because it's a numerical process, these are all zeros. Actually, the real answer here would be y equals negative 0.8 and stop. And that really is the exact answer.
I have one question. Can you do the lights? I can't see the screen really.
See if this helps.
Yeah, that's okay. And then when I put that.
And we should have enough light for y'all to see for that.
And then when I put that in my calculator, when I do that mate and type that in like the right way, and then press enter, it's not bringing me to the screen. You don't put it in y equals, right?
You don't have to put it in y
You have
equals.
to, okay.
If you want to put it in y equals, the reason you're going to do that is because instead of using this, you're going to actually graph it. Maybe the problem said to graph it. So you're going to actually graph it, and then you do the dy dx, which is number 6 on calculator.
Okay, but if you do 8, yeah, I got the right one, so yeah.
Yeah, okay. Be sure you have one way to do it. Be sure you can do it a way that works for you every time. So just for the sake of people that want to know both ways, if I told you graph y and then find the value of its derivative at x equals 1, well, when you graph y, then x times second e to the x, then a comma, then x, whoops, no, not yet, sorry. Delete, because all I want there is the function. And then I'm going to go on the window. I need to make sure I can see 1. So from negative 2 to 5, I'm going to be able to see 1. So I'm going to go to zoom 0, which is fit the window to these x values I showed you. So there goes the function. And I can see from that function that I probably need to go down a little further. So I'll just keep moving my screen around until I'm sure I'm going to see it if I'm trying to find a graph. And then I go second, trace, choose number 6, which is the derivative. Tell it what value of x you want. We want 1. And it says the derivative is 5.436. So 5.44 would be okay. Okay? If you do it on screen, you should get the same answer. So nDeriv, I'm just going to change the function. X, second e to the x with respect to x at the value 1. So you can do it on the home screen or you can do it on the graph, depending on whether you wanted to graph it to begin with. And then x ln x at the value e. Remember, e is a number, so all you do is hit second ln and then give it an exponent of 1. So it's e to the first, which is just e. And that means that the derivative is actually 2. This is a numerical process, but the derivative actually is 2. It would round off to 2 anyway. Now, if you were doing this by hand, this is how you find y prime, just for the practice. Y prime is a product. It's x times ln x. So because it's a product, the way, I'm sorry, that's not y prime yet. The way we find y prime is we take the first one, which is x, times the derivative of the natural log of x, which is 1 over x, and then we're going to add the natural log of x, and the natural log of x is going to be multiplied by the derivative of x, which is just 1. And since x times 1 over x is equal to x over x, and that's 1, then y prime equals 1 plus the natural log of x. And if you evaluate 1 plus the natural log of e, because it says at x equals e, what's the natural log of e? 1. So the thing to remember here is that you can do the arithmetic, but just to be sure you're getting the right answer, you probably, especially if the functions are a little complicated, you probably want to go ahead and do the nDeriv just to check your arithmetic, because it's going to do it right as long as you put the function in right. So let's look at a compound interest problem. You had one like this on your You had one like this on your practice test. So it says, this is my formula. If a sum of $1,000 is deposited into an account that pays R% compounded quarterly 4 times a year for 12 years, which is where the 48 comes from, this gives you the formula to find it, and the interest rate is the variable. So in order to find the derivative of that, when R is equal to 5, what we're going to do is we're going to do nDeriv.
So we can do these on our test, but we don't have to show them
Show me what you wrote out on your, what you put in your calculator.
what we can do on our phone.
Yeah, because if you've left out parentheses, at least I can tell that's why you got the wrong answer.
Okay, but we don't have to do them by hand.
You don't have to do them by hand. That was the whole point of doing this today. Okay, so your function is 1,000 times 1 plus the interest rate, which is your X value, divided by 400. And it's going to do this division before it does the addition. And then you raise that to the 48th power. So there's your function. Then you put a comma, then X, then a comma, and then the 5. And since you opened a set of parentheses there, you've already closed them, so you don't need another set of parentheses. You just hit your comma, your X, and your 5, then close the parentheses and hit enter, and this is the answer that it gives you. And since we're talking about that A is the future value, A is money, okay? So the derivative is money per, it's not year, it's per 1%, it's per 1% interest rate. Okay? Because remember, R is an interest rate, so it's per 1% increase in the interest rate. The way you interpret that is you say at $1,000,
Wait, how'd you get 1%?
unit, 1, per every
So you
percentage
say
point.
per percentage.
Hmm? Well, it needs to be percentage increase or decrease. Yeah, you could say percentage change in R. But it's the idea that you're going to go up by some increment in R. It's based on the change in the interest rate. So $100 compounded quarterly for 4 years, I'm sorry, for 12 years. Is increasing let's see, we probably need to say the future value is increasing. By $215.15 per percentage increase in the interest rate. In other words, if you went up to 6%, then that would mean your future value is going to be an additional $215 at that point. It's going to be adding $215 every time you increase another percentage point. Okay? Last one. Talk about profit. Yes?
Is that $250 per year or per quarter?
No, it doesn't matter. Your future value is actually how much that's in the bank at any particular point in time, but the variable here isn't the time, it's the interest rate. So if you increase the interest rate by 1%, that means your future value is gonna go up $215.15 in that 4-year period, or that 12-year period, every time you boost up the interest by 1%. So at 2%, it would go up $430.30. If you left it in the bank, compounded quarterly, at 7%.
So in other words, it'd be $250.15 per
Yeah.
1%.
Every time you increase the interest rate by a percentage point, then your future value is gonna increase by $215.15. So the variable isn't the amount of time it's in though, it's the interest rate. We're comparing the same compounding time all the way across. Okay?
Doesn't ours stand for interest rate though?
Yes.
So it says find and interpret what it is when the interest rate is 5.
Find and interpret the derivative when the interest rate is 5. The derivative says, how is my future value, which is A, changing? If I increase the interest rate, what impact, if I deposit the same amount of money for 12 years, compounded quarterly, whatever the interest rate is, if I am at 5% and I decide, well, you know, what if I put this same amount of money in the bank for 12 years, compounded quarterly, at 6%? Well, then my future value is going to be $215.15 higher. Okay, if I go to 7%, then my future value, still for the same term of leaving it in the bank, everything else is the same. My interest rate goes to 7%, then my future value is going to increase by $430.30.
Do we
Okay?
have to include the 5 anywhere in our answers, like however?
Not really.
Okay, just want to make sure.
Yeah, because that's actually what we're starting out. That's your beginning condition. Okay? And actually, if your interest rate went down, you could still interpret it the same way. If your interest rate was 4% instead of 5%, then your future value on that same investment is going to be $215.15 less. Okay? So just remember, this is a rate of change, but it's based on the change in the interest rate. The rate of change in the future value. Okay, in profit. Suppose your profit's given by this function. Find and interpret the marginal profit, which means the rate of change of profit when the following numbers of units are sold. In this case, because I've got 3 different values of X, I can either do it on screen, as long as you remember that your calculator will actually repeat the last thing you put in by just hitting second enter. Your derivative needs to be x squared divided by the quantity, or your function needs to be x squared divided by the quantity 2x plus 1. So you are going to need some parentheses. So we're going to take that derivative with respect to x, and the first value is 4. So the answer to A, P prime of 4 is 0.493 would be 0.49, and it says the profit in hundreds of dollars So when I'm doing profit in hundreds of dollars, 1, 2 decimals, that means $49.38. That's because it says in hundreds of dollars, so you need to move your decimal. P prime of 4 is $49.38 per additional unit. So the way that you would interpret that is when 4 units of the product are sold, the profit is increasing by $49.38 per unit. Now, the practical interpretation of that is that if you've made 4 units and sold 4 units, your profit on your next unit is going to be $49.38 for the 5th unit. That's a more practical way of thinking about that. But that tells you what's happening. And then all we have to do now is hit second enter and change that last value to 12. And it's $49.92. So when 12 units are sold, the profit is increasing by $49.92 a unit. And then last is 20 units. And that's $49.97. So then the question says, what's happening to the marginal profit as the number sold increases? It's increasing slowly. So it's increasing slowly as more units are produced. Now the last question is about the marginal profit. Not just marginal, but marginal average profit, which is a very different thing. Marginal average profit says that P of X has to be divided by X to find your average profit. So this is P bar of X. And if you divide this function by X, you're going to be multiplying it by 1 over X. So that function is going to be X squared over 2X squared plus X. Because X times 2X plus 1 is 2X squared plus X. And that means that we need the derivative, P average prime, and it specifies at 4 units. So we can go over here. Actually, let me just clear it. And we can change this into marginal average profit pretty easily. So we're going to use nDeriv there too. And your marginal profit at 4 units is, I remember this is hundreds again, so we're going to move the decimal 2 places, so it's going to be 1.23. So it's worded pretty much like this is, except you say at 4 units sold, the average profit is increasing by $1.23 per additional unit. But it's the average profit that's increasing, not the profit itself. It's the profit spread over all the items. Now, what that actually means in a practical sense is that as you make more and more and more items, your profit being spread over those additional items, your profit per item actually gets a little bit bigger because it's increasing. So it's growing a little bit. If this is your profit per item, like if you make 4 items, your average profit for 4 items is going to be a lot less than your average profit for 20 items. Because once you spread your profit over 20 items, then you have a little bit less of an increase. Okay? So you have your test. Message me and show me. As soon as I get back to my office, I will put up the alternate instructions page for you that actually has your instructions on it. You can rip off that cover page and put your cover page on it. If anybody has any questions, ask them and show me, but if you're needing to know, you know, right now and it's kind of late, you might want to send me a message and remind to let me know that you've asked the question and show me. Because I don't sit with Shelby open all the time, but my phone is sitting there and it'll ding if you send me a message and remind me. So I'll go look.
So when is the exam due?
Thursday, at the beginning of class.